Welcome back, everybody. Last time we very vaguely discussed hypothesis testing. We didn't even talk about specific types or context for the test. We just said, this is what it looks like, some of the logic behind it. And I mentioned finding p-values versus critical values. Well, now we want to focus that a little bit and give some context. And so we're going to start by looking at claims made about a population proportion. Okay, so the context here is that a claim has been made about a proportion and we want to test it. So the requirements: simple random sample. We need the conditions for a binomial distribution to be satisfied, and we need at least 5 successes and 5 failures, according to P and Q, as defined by the binomial distribution. Now, where's this coming in? Well, that's because we're going to use a z-distribution, which applies to normally distributed data, which applies to continuous data. This gives us, or allows us to employ the normal approximation, okay? So that's what's going on with this condition being met, okay? And so we have our test statistic, okay? And this is our formula for it. Now, of course, we can compare with the critical ZC. There'll be some region. We will have 1 or 2 critical values depending on the type of test. And then this Z will be either in this region or in that region. And depending on which region will dictate whether or not we reject or fail to reject the null hypothesis. Again, this region over here is the fail to reject the null. Okay. So let's take a look at an example. According to a recent US news report, more than 40% of teens text while driving. That is a claim. In fact, I can mathematicize that claim. P greater than 0.40. Okay? Now, we need a simple random sample. We want to test this. A simple random sample was taken. It was found that 52 teens, out of those 52 teens, 22 admitted to texting and driving. Okay. Now, NP greater than or equal to 5, NQ greater than or equal to 5. Well, yeah, right, we got 22 successes, which means we have, what, 33 failures, so we're good. Okay, now, I have my claim. Let's set up our hypotheses. So my claim I'm going to place first. P greater than 0.40. My null then will be P equals 0.40. Now I like to include a little reminder of which of these is my claim, right? More than 40%. All right. Now, notice that there is no significance level given. If there's no significance level given, we have control over what that is. And I think it would be good, just as a good practice, to choose 0.01 for our significance. So we have alpha is 0.01, and this is right-tailed. Okay, right-tailed. So what I want to do is place my critical Z value in the right spot. My alpha is 0.01, and this is right-tailed. That means there is an area of 0.01 in that right tail. And this will be my ZC. Okay. We still need to figure out what that is. But again, we have our regions, right? We have our rejection region that's shaded. And then we have our fail to reject region over here. So let's go get our ZC. Well, we know that if there's 1% in that right tail, then there's 99% sitting to the left. So I'm going to do inverse norm, an area of 0.99, and we get 2.326. 2.326. Okay. So this is now my measuring stick. This is what I'm going to use to measure my test statistic against, okay? So now we need our test statistic. Okay. If you want, you could think of this as two columns. I'm just moving my work over here. So our test statistic comes from this formula, p hat minus p all over the square root pq over n. Well, p hat, and yes, that's how you pronounce that, p hat. That comes from our sample. And so p hat is going to be, well, 22 over 52. Now, when I do this computation, I'm going to leave it as 22 over 52. I could reduce it if I want, but my point is I'm not going to treat it as a decimal because I don't want to round it. And then minus p, which was from my claim, right? 0.40. And then divided by 0.40 times 0.60 all over n. So let's do this. Let's see what we get. So 22 divided by 52 minus 0.40. And then I'm going to divide that by the square root of 0.4 times 0.6 divided by 52. And we get 0. What did we get? 0.3397. If I'm rounding, 0.3397. All right. Well, where does this z fall? Well, it falls in here somewhere, right? Zero's in the middle. My critical is out here at 2.3 something. So it's in the fail to reject region. Well, fail to reject what? The null, okay? Now let's think about this. There's a logic here, and I'll summarize it later, but I want you to struggle with it first. Our claim was the alternative. The null, then, is everything that's not the claim. And we are saying that whatever is not the claim, we're unable to reject, which means it could be true. And as long as it could be true, does that support the claim? No. So let me say that again. What we've shown is that everything that's not the claim may or may not be true. We can't say that it's not true. So it might be true. Well, because they're complements, they both can't be true. So that means the claim has not been supported by this evidence. And so we would say at alpha equals 0.01, there is insufficient evidence to support the claim that more than 40% of teens text while driving. Okay. All right. You're going to find that the steps up to here are going to feel very natural. But then there's going to be some serious logic brain twisting to get this out. Again, I don't want to give you some nice scripted recipe to just always tap into. I want you to think about it. So I wonder if our calculators can do this. I would love for the answer to be no. Nope, they don't. Sorry. They do. So let's go take a look. Let's come over to our calculator. And I want you to go to Stat Tests. And under Tests, you will see one prop z-test. One for one sample, prop for proportion, and it's a z-test. Enter. Now, P0, that's the claim. So we are saying that that's 0.40. X, the number of successes from our sample, was 22. N was 52. And then our last, or not our last, but this line down here where it says prop, this is the alternative hypothesis. And we are saying more than 0.4, okay? And then we hit calculate. Hey, what do you know? Right. There's our Z, okay? So there's our Z, and we can make a decision, okay? If you want to use the p-value that we talked about yesterday, there's the p-value as well, okay? Notice that p is larger than alpha. So our calculators will absolutely do this for us. So well, let's let them. All right. How about the next one? USA Today reported that 44% of homebuyers find their real estate agent through a friend. The survey finds that 722 out of 1,762 homebuyers found their agent through a friend. Is the claim accurate at 0.02 significance? Well, again, first step is to mathematicize the claim. 44% of homebuyers. We are saying that P equals 0.44. Okay. So now we place it. Null or alternative. Well, notice my claim now contains the equality, right? So that's my claim. My alternative then is P does not equal 0.44. So we have alpha is 0.02. We have a two-tailed test. So let's draw this. Remember, there's going to be an area of half an alpha in each of these tails, half alpha, right? Here is my fail to reject region. We need our critical Z's, okay? So we're going to get those by coming over to our calculator. And I'm going to say inverse norm. And then the area to the left of that first one is 0.01. And so my critical Z is negative 2.326. Negative 2.32. 2.326. So I know this one is positive 2.326. Right? So now I've got my measuring stick. I'm now going to compare my sample. Well, my sample, 722 out of 1762. This is where I go to one prop z-test. And when I do that, and this is fine, just tell me where this is coming from. It's coming from this one prop z-test. And when I do that, what do I get? Well, show you my calculator again. Stat tests one prop z-test. So our claim is P equals 0.44. And then my survey, I had 722 successes, 1,762 total in my sample. My null is not equal to, okay? And we calculate. So we get z equals negative 2.557, negative 2.557. Well, where is that? That's out there. This is a reject HO. Well, in this case, the claim was in HO. So rejecting the null is also rejecting the claim. And so I say alpha equals 0.02. There is sufficient evidence to reject the claim that 44% of home buyers find their agent through a friend. Okay. All right. So again, you're seeing some general procedure here, right? We mathematicize the claim. That's the first thing we do. Mathematicize the claim. That's my term, mathematicize. And then we write the hypotheses. Then we set up the regions. Then we get the test stat, or standardized test statistic. Then we make a decision about rejection of the null, and then we write a statement. Okay, those are the those are the general components in a hypothesis test. Okay. All right, let's try one more, and maybe you want to pause this and try this one on your own. So I'd encourage you to do that. All right, hopefully you tried it. Here we go. You're employed by an environmental conservation agency that recently claimed more than 30% of consumers have stopped buying a certain product because of its environmental impact. You randomly select 1,050 US consumers, and you find that 32% have stopped buying the product. Test the claim at 5% significance. All right. Well, first, we need a claim that is mathematicized. More than 30%. Well, it's a claim about a proportion, so P, more than, greater than 30%. Okay. Now, I can write my hypotheses. My alternative, right, again, the null has to have equality. So the claim does not contain equality, right? It's strict greater than, more than, greater than. So my claim has to be down here in my alternative, which means my null is P is less than or equal to 0.30. I'm just going to say equal to because that's more conservative. There we go. Do we have 5 successes and failures? Yes, right? 32%. Stop buying the product. Okay. Well, let's set it up. Alpha equals 0.05. And we have right-tailed. So what does this look like? Well, it's going to be right-tailed. That area down there is 0.05. We want to find that critical Z. And so we can come over to our calculator. We know that inverse norm will give that to us. And if that entire 0.05 is contained in the right tail, then there's an area of 0.95 left of my critical. So we get 1.645. Of course, we have our regions now. Fail, to reject, HO. All right, the test statistic. Well, if you notice here, I don't have a raw number, right? I have 32%. P hat is 0.32. Or if I want to use one prop Z, right, I need to figure out what's 32% of 1050, right? That's really my X. So one prop Z test. That's what I want to do here. And I will show you that. Lovely birds out right now. Uh-oh, wrong one. All right, so 0.30, that's my P naught. And then X, what I'm doing here, 32% of 1050. I'm just gonna type that in. Oh, and it gives it to me. What do you know? And then 1050. My alternative is greater than. And now I'm ready to calculate. We get 1.414. 1.414. So notice this Z is not in the rejection region. So we fail to reject the null. And if the null is not the claim is the alternative, then we have not supported this claim at all. So at alpha equals 0.05, there is insufficient evidence to support the claim that more than 30% of consumers have stopped using a product because of its environmental impact. Okay. All right, guys. So this was our first test for proportions. Again, I want you to see the big picture. We mathematicize the claim. we set up our hypotheses. We find our critical value, which breaks us into a fail to reject region and a reject region. We then run our test stat, 1 prop z if you're using a calculator, and then we make a decision on what to do with that pesky null hypothesis. Once we've done that, we reinterpret that decision within the context of the claim, okay? It's a very prescriptive procedure. You do this, then this, then this, then this, then that. But there is a logic going between that step of deciding what to do with the null and interpreting in the context of the claim. Because think about it, that claim could be the null. In that case, the claim would be rejected or not. Or the claim could be in the alternative. And so what does a rejection or fail to reject of the null mean in terms of the claim when the claim is in the alternative hypothesis? That's something that I could just tell you, or something I could let you struggle with. I think I'm going to let you struggle and tell you later. So work through the logic, okay? And yeah, that's it. When we come back, we'll do this again, but instead of talking about proportions, we'll be doing a hypothesis test for a mean. All right, until we meet again.